All right, we're going to talk about types of variation. We have a few to talk about. We've got direct, we've got inverse, we've got joint, we've got combined. They're all not bad, and they all have keywords to help you. Direct. As one variable does something, the other variable does the exact same thing. As x increases, y increases. As x decreases, y decreases. So an example of this would be the circumference of a circle. As the diameter increases, the circumference does, because a larger diameter means a larger circle. The equation for direct is just y equals kx. K is some constant of variation, and you have to find it every single time you work one of these problems. And that's okay. That's the first part you have to do. It's basically a two-part problem. Find K, and then find the actual answer to the problem. So let's take a look. The Ford F-150 can travel 150 miles on 10 gallons of gas. So it can travel 150 miles on 10 gallons of gas. How much gas? How much gas is required to travel 750? So you see how the first part of the first sentence tells you pieces of information, and the second piece tells you the question to figure it out. So we've got to figure this out. Direct variation, y equals kx. Y, 150 miles, x, 10 gallons of gas. But I don't know what k is. That's all right. I can solve for k. Divide the 10 over will tell me that k is 15. Now that I have k, I can go figure out the answer to the problem. It says how much gas. I don't know what x is, but I know I want to go 750 miles. And bonus, I know what k is now. Using again our direct equation, y equals kx, y is 750 miles, k we found out to be 15, x I don't know. Divide the 15 over, that tells me x is 50 gallons. Always find k first, then you get to solve the problem. Inverse variation. As one variable does something, the other variable does the opposite. So as x increases, y decreases. So the faster you go, right, the faster you drive, the shorter your trip is, right? The faster speed increases, time decreases. So that's an inverse relation. Here's our equation. Go back and look. Direct was multiplied. Inverse is divide. That kind of should make sense. So let's take a look. If you travel 8 hours at 50 miles an hour, find first the constant of variation. And then, how fast would you need to drive to arrive in 6? All right. So you travel 8 hours at 50 miles an hour. So you've got y is 50, x is 8. Multiply your 8 over. K is 400. Now I know k. I can figure out the problem. It says how fast? How fast would you need to go? I don't know why. How fast? In order to get there in 6. 6 hours, time. So x is 6. K I know. Divide these values out. It says that, well, you need to go about 67 miles an hour. Joint. Joint variation means that it varies directly to 2 or more. All right, let's go back and think. Y equals kx. That was my direct variation. Now, joint is just, it's direct, but with 2 or more variables. Just throw another variable on there, and that's our equation. Okay, so it's just direct, but just a little more. So here I've got my joint variation equation. So in geometry, the volume of a cylinder, it says it varies jointly, there's your keyword, with the square of the radius, so r squared, and the height, h. Okay, so it's telling you the pieces in order to write out your equation. Let's see. The energy that an item possesses due to its motion, it's called kinetic energy. The kinetic energy of an object, which is measured in joules, varies jointly, there's your keyword, with the mass of the object and the square of its velocity. So we have the mass of the object and the square of the velocity. And energy. We need another variable, y. So y is the energy, x is the mass, and z is the velocity. If the kinetic energy of a 3-kilogram ball, that's my mass, traveling at 12 meters per second, that's my velocity, is 216 joules, that's my y. All right, now, if earlier I was pointing out which is x and which is y and all that, and you were getting confused, let's read this sentence again. If the kinetic energy of a something at something is your kind of a keyword to say equals, so you can figure out the value, which variable is y. What's the mass of the ball? What's the mass? What is x? Right, this is the second part of the problem. What is the mass? The ball generates 250 joules of energy when it's traveling this fast. So that's the second part. We got to figure out the first part. All right. It said varies jointly with the mass and the square of the velocity. So y equals with the mass and the square of the velocity. Okay. Y is energy, x is mass, z is velocity. It told me that it's a 3-kilogram ball, so x is 3. It told me that the velocity was 12, so 12 squared. Oopsie. It told me 12 squared. And it said my amount of energy was 216, so y is 216. So 3 times 12 squared, 3 times 144, you get 432. Divide that over, k is a half. Now that I know k, I can go ahead and I can figure out that part of the question, the second part. What is the mass? What is x of a ball that generates this much energy? Y is 250. When traveling, 10. So z is 10. Okay. So let's go ahead and figure this out. We've got y equals kx z squared. So y equals 250, k is 1/2, x is I don't know, and z squared would be 10 squared. So we've got 1/2 times 100, so that gets you 50. Let me try and clean this up a bit. That gets you 50. So then now you have to divide by 50. Oopsie. So then you have to divide by 50. So now you've got 250. Oh, excuse me. You've got 250 divided by 50. So you'll get 5. That tells you the mass of the ball needs to be 5 kilograms in order for this to be answered. Combined variation is a combination of direct and indirect. It says some quantities are going to be direct and some are going to be indirect. And so basically we're going to have some that are going to be multiplied and some that are going to be divided. And the nice part is that it's going to tell you which one is which, okay? An empty can of room freshener that has a volume. You know what? Here, let's do this. An empty can of air freshener that has a volume of 350 contains gas at a pressure of, at a temperature of. All right. It tells you right here, pressure varies. That means pressure is Y, varies directly with temperature, Means X is temperature because directly is the one that gets multiplied. And inversely with volume, which means that this one is volume. Well, this helps tremendously because now I know exactly what all the variables are. Y is pressure, X is temperature, and Z is volume. Determine the temperature of, and then this is the question, right? This is the question. Determine the temperature of the same can if it contains a gas pressure that's changed. All right. First, we have to go and figure out, okay. So I have a can of freshener. It has a volume, that's Z, of 350. So Z is 350. Contains gas at a pressure of 360. Pressure, that's Y. So Y is 360. At 24 degrees, that's my temperature, that's X. Plugging into my equation, I get 360 equals K times 24 over 350. Multiply the 350 over, then divide the 24. You get K is 5250. Once I have K now I can go answer the question. What is the temperature? I don't know. Of the exact same can if the pressure Y changes. Okay, what is, the pressure is now 750. K I know, 5250. X I don't know the temperature, but I do know that the volume is the same, so it's still 350. Again, multiply the 350 over, divide it out, and you get X is 50 degrees.